In this video, we are going to be looking at problems on meter bridge. Let's quickly look at this example. The meter bridge shown below is in a balanced state. The resistance per unit length of the meter bridge wire is 1 ohm per cm. Find the unknown resistance X and the electric current flowing through it. Here, this is the unknown resistance X, and this is the point where it balances. The unknown resistance S on the left hand side and the known resistance 3 ohm on the right hand side. The balance point on the left hand side is 40 cm and the balance point on the right hand side is 60 cm. The EMF of the battery of cell is 6 volts. Now we are going to use the meter bridge formula to find this. We know that for a meter bridge, R1 over R2 is going to be equal to L1 all over L2. L2 is actually equal to 100 minus L1. So you can see from the diagram that L1 is 40 cm and L2 is 60 cm, which is 100 minus 40. Now R1 is X divided by R2 is 3 ohms, which is equal to L1 is 40 cm divided by L2, which is 60 cm. And I cross multiply, I'm going to have X is equal to 40 times 3 divided by 100 divided by 60 rather. So this is going to give us 120 divided by 60, which is equal to 2 ohms. So the resistance of X is 2 ohms. Now in the other part of the question, we're going to look for the current flowing through the meter bridge. So to do that, we know that the X and the 3 ohm resistor are in series and they are together combined is parallel with the meter bridge. Now what the resistant wire of the meter bridge. So what we are going to do, we know that the resistance per unit length of the wire is 1 ohm per cm. So from there we can get the resistance of the wire. So if the length is equal to 40 cm plus 60 cm, that is the length of the resistant wire is equal to 40 cm plus 60 cm, which is equal to 100 cm. So we know that that's the length of the resistant wire of the meter bridge. Now if the length of 1 cm has a resistance of 1 ohm, it therefore means that 100 cm is going to have a resistance of R equals 100 times 1, or 1 times 100 ohms. So that's going to give us 100 ohms. So the resistance of the wire is 100 ohms. Now let's see. Remember I said that X and the 3 ohm resistance are in series, so their combined resistance, which I'm going to call R1 or R2, is going to be equal to 2 which is the resistance of X, plus the 3 ohm resistance rather. So that's going to give us 5 ohms. So that's the combined resistance. Now the resistance of the wire, which is R, is in parallel with R2. So for parallel resistance, their combined resistance is R. I call that R total, RT sub T equals R1. So that's R1 is going to be R times my R2, which is the resistance of the combined resistance in series, divided by R1 plus R2. So my R total is going to be equal to 100 times 5 divided by 100 plus 5. That will give us 105. So when I multiply that, I'm going to have 500. 100 times 5 is 500 divided by 105. And that is going to be equal to 4.76 ohm. So the R total is equal to 4.76 ohm. Now the current flowing through the meter bridge is going to be V divided by R total. That's from Ohm's law. And the voltage is 6 volts divided by 4.76. And that is going to give us 1.26 ohms, ampere rather. So my result is going to be 1.26 ampere. So the current flowing through the meter bridge is 1.26 ohm, and the unknown resistance we calculated as 2 ohms. Okay, that will be all for this video. Don't forget to